Good morning, cadets. I welcome you back for this computer science class session number 2 regarding data structures. In my previous class, I have discussed about the introduction to the data structure. In that, we have seen what is a data structure. It is a way of organizing the data, how data are represented in the form of a raw data and a data item. Then we have seen what are the types of data structures available: simple data structure and complex data structures. In simple data structures, we have seen the linear list as well as the complex data structures. In simple data structures, the data are arranged in a sequence. Examples of linear data structures we have seen: the list, the stack and the queue, as well as the linked list. Whereas in case of complex data structures, the data is not arranged in a sequence. Instead, they are arranged in hierarchical manner, where one to one, one to many, many to many relationship among the data will be formed. But for our curriculum, we have only simple data structure, that is linear list and operations on linear list, as well as a stack and operations are stacks. About the queues and linked list, it is not there in our curriculum. We will only discuss about the linear list and stacks in the data structure section. Now, to continue where I left in the previous class, let me see once again what are the operations that can be performed on any data structure, simple or a complex. These are common, that is insertion, adding a data, deletion, removing a data element, searching, finding a specific data element, traversal, visiting or traveling all the data elements in a given data structure one by one, sorting, arranging a data elements in ascending or descending order, as well as merging, that is combining elements of two similar data structures to form a new data structure. Now let us start with the searching, that is finding a specific data element in a data structure. Now these operations what we have talked now, we'll talk on the linear list data structure. As we know that a linear data structure forms a sequence generally, or all the elements in the linear data structures are of homogeneous, represented by memory bytes in a sequential memory locations, and finite number of elements will be there in the linear list, is also called by the name array. You can see a list given here, that is 10, 20, 30, 40, 55, 70, 45. These elements are stored in the form of an array or a linear list. And whenever we have a lower bound and upper bound, here lower bound is 0, upper bound is 6, the formula to find the size of the list will be upper bound minus lower bound plus 1. Here upper bound is 6, lower bound is 0, 6 minus 0 plus 1 is 7. So that's how you will find there are 7 elements present in the array. This is our properties of the linear list. Elements are stored in sequence, all elements are of homogeneous type, same data type, finite number of elements will be there, and the size of the list can be computed using its lower bound and upper bound. Now there are two methods are used, two techniques are used to search for searching. One is a linear search, another one is a binary search. What is exactly the linear search? Each element of linear list is compared with the item to be searched one by one, and basically it will travel the linear list sequentially from beginning to the end, or it will terminate wherever the element required is found. Here in linear search, items need not be in any order. Randomly means first element is checked, second element checked, and so on. Generally, this linear search method is suitable for only small lists. What will be the best case, worst case, and average case? The best case will be when the element is found at the first position, because our search is over just in a one search. What will be the worst case? If the element present at the last, then we have to visit each and every element. Suppose there are n element, n number of searches are required. What will be the average case? When item is somewhere in the list other than either first or first, it is a best case. Last, it is a worst case. Average case, anywhere in between first and last. This is what the properties of a linear search method. Now, see here, we are going to see how to write the Python modules or Python programs, Python functions for the linear search. Independently, if we see it as a function here, what exactly we are going to execute these programs, and we'll see how they will work in our Python compiler and interpreter. Now, what is the linear search method involves? Just you can see here, item is the item to be searched. In that, we vary from first element to last element, I in range. Every element right from the beginning is checked whether the required item or not, and if it is okay, if it is found, then it will return a true. And after traversing entire search or entire array or a list, if element is not found, the function returns false. Now let us see how the program here it works now. As you know that this is the function definition which is written before the main, and here we have taken an empty array at the beginning. Then what we should, we will give the size, how many elements we want to enter, and then from first element to the last element we are going to enter the value, and that each value will be appended in the array so that our array is entered. And key is what? It is the element to be searched. This is the basic requirement. First, what you have to do, what is the size of a array? Then you have to enter all the elements and append them one by one. And you already know about the append method or append function that we have studied in class 11th. I think nothing should be new in this, because int means we are integer values it will take. What will happen if you don't give int here? Then it will be taken as a int string. That's why the int function is given here. It is a built-in function, and then here key also be a value of integer type to be searched. Now function linear search, which has written a definition here, which is nothing but it's traveling from first element to last element, and every item is checked. If it is there, it was returned true. In our earlier slide you might have seen return true and return false here. So return I is what? What is I exactly? I is the position, index, where the element is found, that will be stored in position. If element is not at all found, none is written in the position. That's why it is checked here. If position is not none, then the element is found at position plus 1. Why position plus 1? Because the array started with 0. So if the first element is also means 0 plus 1. That is the first element. 0 plus 1 plus 1, 2. That will be the, yes, what it will be? 0 plus 1, it is first element. 1 plus 1, it will be second element, and so on. And if the position is found none, if it returns none here, then the element is not found. You can see in the right corner here. For example, if you execute this program, we will enter the size as 5, all the 5 elements you have entered. Okay, value to be searched is 20, and the position of the element 20 is 4. Whereas 6 elements, other 6 elements you have entered, they are not in any order. You can see here unordered elements, and 100 we have searched, and it says not found. Now for your benefit, if you want to execute this program, we will execute this program and see how it can be executed. Okay, let us go to the Python. Okay, here I'll go with a new file here, right? Now rather than typing, just I will copy and paste the code which is already available here. I will copy here this. Okay, of course indentation should be perfect. Here within the for loop, if it is there, then it will return 1, otherwise it will return none. Okay, next here other part of the code is my main program. Okay, this I will paste here now. Okay, array, enter the element, then the for loop. Within the for loop, what will have indentation, very important. Okay, every element within the loop it will be read, entered, and here what you will see, you have to input the value to be searched. Further code is this one, continuation of that. I will paste that one also here. Okay, go through the code, the same thing here. My program is starting an empty array. The size I will enter, 1 to last element, all the enter values I will enter, and then I'll append them. Element to be searched is entered. Then okay, here in case here if position is none, then it will print. Okay, if position is none, it will print found at position. If not none, sorry, if position is not none, it will print there, else it will print not found. Let us execute and see. Before that I will save this program. Where I will save, okay, you can take a particular dictionary, this one, and here I will give it as a linear search program. Save it. Let us run. Okay, unexpected indent. Can you tell me what is the problem here? Yes, before that loop n will be there, then the for loop will be there. Okay, save it once again, run, indent block. Okay, here if return and return none. Okay, this will be the correct indent. Save. Now what is the problem, my friend? Here for indent, no, for will begin from here, then the indent of this D and A. Now I think we should not get an error. Now once again we are getting an error here. Okay, here indent problem. Now save, run. Okay, enter the number of elements. Let me enter 5 elements randomly. Okay, element to be searched is 34, found at position number 3. If I run it once again, right now right, okay, no need to save it once again. Let me run once again. Enter the elements, 5 elements. This time I will enter the element 66 to be searched. Element is not found. That's how the linear search, if if you go through the code here, you can just see once again the code available here. Yes, you will take an empty list, will enter the size, then you will enter each one by one element and append them, and also you will enter a value to be searched. Then your function linear search is called. The value, the entire array is passed to my list. The value to be searched will pass to item. And what is the logic here? The length of the list will be computed from first element to the last element. Every element is checked. If it is there, its position is returned. Otherwise, position will be returned as none. So in this position, either you will get a none or the value of the position. If it is not none, that I plus 1, that position will be displayed. Otherwise, it will display not found. Now, we'll move on to the next search method. As we already discussed, the linear search method is good if the arrays are very or they are reasonably small. When the arrays are large, then we go for the technique binary search. How this technique will work? That is a divide and rule. What divide and rule? You must be knowing what is the divide and rule will be there. Data must be sorted either in ascending. The compulsion rules here in case of binary search is we can only operate the binary search when the list is in sorted order, either in ascending or in descending. Otherwise, this method cannot be used. If the array given is not in sorting order, first thing you have to sort it and then you have to apply the binary search. So how this method works? Initially, we'll find the middle position of the array by lower index plus higher index divided by 2 will give the middle position. Then if the middle element is equal to the required element, then your search is successful. In case if middle value is larger than the searched value, then your search should be in the first half, that is left middle position. Otherwise, it will be the right side of the middle. There are three possibilities. Either required element may be equal to the middle position element, or it may be larger. In that case, first half you will search. Otherwise, you will search the second half, and this process continues till the element is searched or you are dividing the array gets over, so that element is not found. This is in case of ascending order. If it is a descending order, what we will do now? In case of the element is equal, fine. Otherwise what we will do? Instead of, if it is searching left of the middle, when? Yes, is reverse y. Depending on it is a larger or a smaller. In case of ascending, if the middle element is larger, then we will search in the first half. In case of descending, if the middle element is larger, we will search in the second half. That is what. Less time, it's comparing to the linear search, it will take a very less, and it is more suitable for large lists. Let us see how this search method will work now. Okay, first we see the definition, then how we implement this in the main program. What we have done here in the definition of the binary search, having two parameters, the list and the item to be searched. Low is the low position, low equal to the 0 is the beginning index, and the high will be the length of the list, that is the last element. Length of my list minus 1. Why minus 1? Because we are starting with 0. Now, we are putting a loop here that gradually you can see here either high will become mid minus 1 or low will become mid plus 1 within the loop. At some point of time, low will be either greater than high. When it will come out of the loop now, either it should return when the search is successful, or when the low crosses the high, it should come. These are the only two possibilities. What we are doing here now, first we will calculate the first time middle value, and that middle value is equal to the required item. Straight away will come out of the loop and we display the position of the mid. Now, if it is not equal, if the middle element is larger than the required item, then we will search by keeping the low at the same place. high will be reduced by mid minus 1. Otherwise, high will be kept in the same place, low will be, because we have to search for the second half. After searching the entire loop, if never enter into the mid or return mid, or else low is becoming greater than the high, then you will return a minus 1. Here in this binary search, only two possibilities of returning: either search is successful, the position of the middle value, or search is unsuccessful, returning a minus 1. Now let us see here program code exactly. Now once again, very simple. Enter how many elements? We will enter the elements in ascending order. Right from then the value to be searched. Then one by one element will enter here, and then we will append each one element, and totally we are going to enter the array now here. Now the element to be searched is entered in the key. Now binary function is called. Array is passed to my list. Key is passed to item. Means you are going to search for an item in the, as already we discussed in the functions, that these are the actual arguments, ARR and array and key, whereas these are the formal parameters, that is dummy arguments, my list and item. Now once again, mid will be, this position will receive either actual mid position or minus 1 it will receive. If it is a minus 1, search item is not found. If it is not minus 1, item is found at position plus 1. Now if you see the logic of binary search here, what I had written earlier, you have seen here, the same thing is implemented here. Low is 0, high is length of list. As long as low is less than or equal to high, keep on calculating the middle. Then if middle is equal, return it. Otherwise, if the middle element is greater than the item required, keep the low in the same place and high reduce by 1 by the mid. Otherwise, keep the high at the same place and low will be shifted to mid plus 1. Okay, let us execute this. You can see here, once after execute, how the output will be. For example, if there are 8 items are here, all are entered in an ascending order. Item to be searched is 15, position is found is 4. Now 5 elements I have entered in ascending order, element to be searched is 61 and item is not found. Now let us see, we will execute this program in our, here I will go for a new file. Okay, then let me copy this. Oh, it is an image now, we cannot copy this. Okay, okay. Now what you can do is, you can try this program on your own if you have installed a compiler. Okay, if you have a compiler, any of this video will be available with you. What you can do, the same binary search and this main program and the function you type, execute and check it whether this kind of output will come or not. Now, so today we have discussed about the operation only search. In there are two methods, linear search and binary search. Rest other operations we will discuss in our subsequent classes. Okay, boys, thank you.